Hi, my name is Victoria Krist, and the title of my research is a modified approach to storing Delaunay triangulation. Fingerprints are a type of biometric in that they are used to verify a person's identity. In a lot of fingerprinting matching algorithms, minutiae are extracted and evaluated. Minutiae are the points where ridgelines terminate or intersect. So far, more needs to be done in order to evaluate partial prints and be able to use those data. Fingerprints are unique, and they can be classified into 6 different classifications based on their physical features. Delaunay triangulation, coupled with other secondary methods, are used in fingerprint analysis techniques. Delaunay triangulation is a type of triangulation where, given a set of p discrete points, the triangulation yields no point p, an element of p, inside of the circumcircle of any triangle. A visual of this can be seen below. With this, my research consisted of investigating the relationship of resultant triangles after a new data removal method post-Delaunay triangulation. This was done in hopes of reducing the amount of data necessary for matching between an input and template data set. This started with quantifying the connections of each node, also known as the degree of the node, averaging the amount of each type of numerical connection, also known as the weighted average, taking the ceiling of the resultant integer and using this as the threshold. And this is used to implement the removal steps. First, starting with removing all connections of less than the ceiling, and all remaining triangles are stored as set 1. And then doing this again, but removing all connections of greater than or equal to the ceiling, and all preserved triangles are then stored as set 2. And then taking sets 1 and 2 and just looking at which triangles and how many resulted from the removal steps. An example of this can be seen from a fingerprint. On the left is before, on the right is after. For all subsequent figures, those triangles shaded in maroon represent triangles in the less than average data set, and all triangles shaded in blue represent the triangles in the greater than average data set. If you notice, these triangles congregate around the middle and represent the edges of this fingerprint. Because that was done by hand, and doing things by hand leads to a lot of errors, I wrote code for a computer to do this for me. If you'd like to see the code in more detail, please pause this video. Because fingerprinting data is not just widely available to anybody, I use constellation data because in the end, all I'm doing is comparing nodes and the relationships between these nodes. First, starting with Leo, ceiling with a weighted average of 5 yielded 3 triangles. Floor with a weighted average of 4 yielded 9 triangles. Ursa Major, ceiling weighted average of 5 yielded 9 triangles, while floor with a weighted average of 4 yielded 21 triangles. Canis Major with ceiling weighted average of 5 yielded 9 triangles, while floor with a weighted average of 4 yielded 14 triangles. Notice how in all 3 of these constellations, the weighted average for ceiling and floor were the same, and also the yield of ceiling was less than that of floor. And notice too how these triangles were preserved around the middle of these images for all 3. These 3 constellations were used and compared because they all look a lot alike. Notice mostly in the body of Leo, Ursa Major, and Canis Major, they all look very similar. This idea can be related back to fingerprints in that fingerprints within each of the 6 physical classifications have similar shapes, but are still distinct from one another. For future work is to obtain internal angle information of the resultant triangles and compare with images containing similar yielded triangles. Also using stored Leo data arbitrarily against surrounding constellation data to see if the new removal method could match with the Leo embedded within many other points. So just adding more data points to the set. Additionally, the reduction in stored data information for one fingerprint or constellation could tackle the partial print issue, since triangles tend to be favored on the edges and center of an image, shown from the data that I've shown. Here are my references. Thank you.